Inches?
Inches, yeah. Okay, so do the same thing for area, please.
Area is 78.5 inches squared.
Fantastic. Now you have to know these formulas. They won't be given. So you're making a kind of a note card or a, reference sheet. They may want to make their way on there. You can also, you also may be asked to like go backwards, but I can't say for sure. So we'll get to that in a bit. Okay, next types of problems you might see is more of this like square root, cube root stuff. So you're used to some problems where it's like the square root of I don't know, we'll say 144. And you know that's 12. But what if it's like x to the 10th? Well, you might know, okay, I just divide that in two. Okay. Well, what do you do if it's x, or I'm sorry, y to the 13th? What if it doesn't divide evenly? Do you remember how to approach something like this?
Um, I don't really remember.
Okay. So no matter what it is, you're going to break it into three separate problems.
Okay.
Okay. Square root of 144 is 12. Square root of x to the 10th is x to the 5. The reason is the square root is like 1/2 power because there's really a 1 there, and a 2 is the index. So half of 10 is 5. And you might think, well, why can't I just take half of 13? Well, you can, but you got to give it to them in the form they want, which is different than just a decimal. So we're going to actually break apart the y to the 13th into y to the 12th times y to the 1. This means that it still is y to the 13th, but then you can break that apart into the square root of y to the 12th, square root of y. The square root of y does not reduce, but the square root of y to the 12th does. Okay, what does that become based on what we've been doing here? Last, like the square root of x to the 10th became x to the 5th. What does the square root of y to the 12th become using the same
Um, y to the 6th.
y to 6, right? Just like that. And so you pair the stuff up that's outside the root and keep the stuff inside the root that's doesn't have anything that doesn't reduce further. Okay, so let me give you one like this, and then I'll also give you one different types of problems. Let's any questions on that though before we move on? Because I'm going to give you one kind of like it where you got to break it apart and do some things with the exponents.
No, I don't think so.
Okay, so let's try it out here. Let's go square root of 36 x to the 5th, y to the 8th. Go ahead and reduce that for us, please.
If you have a square root left over, does it go on the end or does it go next to the same
Yeah,
variable?
it stays to the right, even if it's like in the middle.
Oh, okay. I got 6x squared y to the 4th square root of x.
It's very good. Perfect. Okay. Now the same thing applies to, for example, a cube root. Okay. Let's say it's the cube root of 8 x to the 9th y to the 12th. Okay. Um, so this time it's the cube root of 8, the cube root of x to the 9th, and the cube root of y to the 12th. And the cube root is to the power of 1/3. So it's like dividing, it's like in case of the variables here, exponents here above the variable, you're dividing each one by 3. So these become x cubed. 9 divided by 3 is 3. That's where the 1/3 comes in. And y to the 12th becomes y to the 4th.
Okay.
Now the cube root of 8, that's a known value, right? That's just 2. Okay, but do you see how you see how those exponents reduce?
Yeah, I can kind of see it.
Okay, so let's do another one here. How about the cube root of 27 x to the 15th w to the 30th power? So could you try to reduce this for us, please?
Is it 9x to the 5th w to the 10th?
Perfect. Okay, very good. Now we're going to look at a problem here. I just need 30 seconds. I'll be right back. Sorry, I got just distracted here.
Okay.
All right, I'm back. So let's look at another problem here. Let's look at something like this. The cube root of x to the 10th, y to the 17th. Okay. Does 10
Okay.
divide by 3? Does 10 perfectly divisible by 3?
No.
No. So this is a problem. Okay. And the problem is we now have to make 10 into something that is divisible by 3. So you always go down. Is 9 divisible by 3?
Yes.
So this becomes x to the 9th times x to the 1 cube root. Okay. Cube root x to the 9th times the cube root of x to the 1. What does the 1 on the left become? The cube root of x to the 9th.
That becomes x to the 3rd.
Very good. Now we're gonna do the same thing for the y, okay? It's the cube root of y to the 17th, but 17 is not divisible by 3. So can you make it into something that is like, if you go down to 16, is 16 divisible by 3,
No.
but is 15?
Yes.
It is. So we can break this apart into the cube root of y to 15 times y squared, and then break that apart into like this. What does the one on the left become?
That becomes y to the 5th.
And the other one becomes nothing because you can't do it. There's nothing to do. But now you can combine. So there's stuff that stays outside, x cubed, y to the 5th, and then there's stuff that stays inside, x, y squared.
Okay.
Any questions on that before I give you one to try on your own?
No.
Okay. All right, so let's try this. Let's try the cube root of 125, a to the 19th, b to the 21st. So take a look at that. Let me know if you have any questions. What are you doing on this one?
So I got 40 a to the 6th, b to the 7th, and then cube root of 5a.
Okay. The A in here is correct. 125 is a perfect cube root. 5 times 5 times 5.
Oh,
So
okay.
there's a 5 on the outside. There's only a few that you need to know. We can do them real quick. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. These are probably all the ones that you would want to know on the right here.
Okay.
All right, so all of that led up to doing, and this will be the last problem of this type that we'll do, just to, and I know it's going to look different, but it's in principle, it's the same. You are going to take a cube root of something, some stuff will come out, some will not. This would be the type of problem you might see on a placement test, see if you remember your exponent rules here. If you can, you should reduce. Does anything reduce inside here?
Yes.
Give me more information. What reduces and what does it reduce to?
The negative 16 and 2, that could reduce to -8.
Okay. All right. So for this problem here, you can take the cube root of the top and then the cube root of the bottom. So will you give that a try and see what you come up with? And don't worry about the negative. That'll come out as well, or you can just ignore it for now if you're not sure. Any questions for me, or do you want to check your answer?
I got -2x cube root -2x over cube root y to the 6th.
Okay, remember, you would just break these apart like the previous one. So like you take the cube root of -8, the cube root of x cubed, and
Mhm.
because the powers are divisible by 3, you can just divide by 3. That exponent of 3 gets divided by that 3. Same with the 6 down here. You're dividing the 6 by the 3.
Oh, okay.
So it becomes just x there. 3 divided by 3 is 1. How about 6 divided by 3? That's 2.
2.
And then the thing with the negatives is it looks odd at first, but -2 times -2 times -2 becomes -8. So that is -2. Would you like
Okay.
one more of these, or do you want us to move on to another problem?
Maybe just one more.
Okay. Let's try the cube root of -64 x to the 9th power y to the 15th power.
Negative 4x cubed over y to the 5th.
Perfect. Okay, very good. All right, so you can see it's pretty intense on algebra. We're going to next look at composition. Okay, so composition of functions. All right, so they will give you at least 2 functions. I'm going to give you 2 functions right here. F of x will be 2x minus 3, and g of x will be 4 minus 2x. And if you remember, composition means to put one inside the other.
Mm-hmm.
So like if I ask for f bubble g of x, this means f of g of x. That letter on the right, the g, fog, g of x, that's the inside one. So you take the inside one and you put it in for x and the one on the left. So wherever you see the x, you replace it with 4 minus 2x. So f of g of x means 2 times 4 minus 2x minus 3. Hopefully it's clear. You're taking everything that's in g of x and putting it in for x here. And then you
Yeah.
have to simplify. So here, simplify, you distribute the 2 to both. That's 8 minus 4x minus 3. And then you combine any like terms. So this would be 5 minus 4x, like that.
Okay.
But we can also go the other direction. So let me go the other direction. So this time I want g of f of x, or sometimes it's pronounced goff. I guess I've learned here working with students over the years. Imagine knowing all the math you ever needed to know and not knowing that this is goff, but that's what some students say. So I go with it. This means to take f of x now.
Mhm.
Just getting rid of these parentheses. f of x now and put it in for x. So this becomes 4 minus 2 times 2x minus 3. Now this time you distribute the -2 to both. So that's minus 4x plus 6. The -2 times 2 is -4. -2 times -3 is positive 6. And then again, you combine like terms, 10 minus 4x.
Okay.
All right. So I'm going to give you two functions and ask you to do the same thing before we move on to some more complicated problems. But any concerns or anything you feel like you might not be able to do with this?
So far I think I'm good.
Okay. So we'll do different functions here. We'll go h of x equals 3x plus 5 and L of x equals 4 minus 3x. So there's two things I want. I want h of L of x and then also want L of h of x. So make sure you get the right one in the right order. And if you have any questions, let me know. But whenever you get one done, let me know and I'll check your work before going on to the next.
Is it 17 minus 9x
Or which one?
for the one on the left?
On the left. Okay. Yeah, let me double check here. You're taking the 4 minus 3x and you're putting it in there. So that's 12 minus 12x plus 5. I've got 17 minus 12x. Take a look at what you've got. Is that similar or not? And if it's not, let me know if I need to clarify anything. You take the L because it's the one on the right and put it in for X. Wait, I'm sorry. I missed multiplied here. 9. That's terrible. Asking you if yours is similar. Hopefully you said no, mine is right. Now this is correct. 17 minus 9x. So for the one on the right here, you're taking the h of x now and plugging it in for x.
Okay. I got 9x plus 5.
X plus 5, okay. So 4 minus 3 times 3x plus 5. I'm concerned because there's no negatives, but let's take a look here. This minus 3 times 3x becomes minus 9x. Minus 3 times 5 becomes minus 15. It looks like, well, I'm not sure, but the 9x is negative 9x, and then you're combining 4 and minus 15. So that becomes negative there, minus 9x plus minus 11.
Okay.
Okay, now the other thing that you might see that we should look at now is that there's also the composition of a function within itself. So let's say I give you f of x equals 4 plus 5x, something like that. There is such a thing as f bubble of x. And it looks a little odd. It's f of x. Means to take the function you have and put it back in itself. So one way that I like to do this and show it is to actually write the function again, and then take the 4 plus 5x and plug it in for x. Okay,
Okay.
so could you attempt that for us, please?
Is it 24 plus 25x? Oh, wait, Matthew, I think you're muted.
Oh, I apologize. Thank you for letting me know. I was waiting for you to work on this. So
Oh,
I guess you didn't hear any of that. So let me restart here. Actually, let me start here. Okay. So we're gonna give you some new functions, and I want you to find a numerical value this time. Okay. So it would look something like this: h bubble f of -1, which means h of f of -1. And that means you first find f of -1. So could you do that for us? Could you put -1 for x over here on f? And then let me know what that result is.
I'm sorry, I'm still a little confused.
So you're using this function on the right here, and you're putting -1 in for x. 2
Oh,
times -1 minus 1.
is it -3?
Okay. Now this time you use the result from f of -1. See how we needed to figure out what is f of -1, and we know it's -3. Instead of the -1, we're putting it the f of -1. We're using the output of it. That now goes in for h
Mm-hmm.
for x. So now you're going to put in -3 in for x, -3 squared. Remember, you really want to do it like that, plus 1. You're using the other function. So you use the first function, and then you use the second function here. So can you give us that result?
Is that 10?
Yes. Yes. Okay. And that's the result it's looking for. Okay. So now let me grab these two functions again. We'll do another example here. All right. So let's go the other direction now. Let's go f of 8 of -1. Okay. So this time you have to first find f, well, it looks like this. It's f of h of -1. So you first find h of -1, which means to put -1 in for this.
Okay. Two.
It is 2. And then so that result goes in for f now. You use the other function for that.
Okay. Three.
2 times 2 minus 1 is 3. Good. Okay, so I'm going to give you two functions, not as difficult as this. We'll do this real quick. Let's say g of x equals 3x and h of x equals 1 minus x. I want you to find g of f of -2 for us, please.
What do you plug in for, or which equation do
I'm
you use?
sorry, I gave the wrong letter. That's meant to be h.
Okay. Um, so
First, what is h of -2?
h of -2 is 3.
Good. And then that goes back in the other one.
And then that one is 9.
Very good. Right. Okay, so we are all done for today. Good job. Hopefully you're getting a feel for